everybody. Thank you very much for being at our monthly Pizza and Programming Seminar. This month we have Dan Berger, who's an associate application developer at ACCRE, as well as in the Department of Physics and Astronomy. And Dan has been working with us for about the last year to give our website a much-needed facelift. And so hopefully folks have had time to visit our website in the last 3 or 4 weeks, but it looks much, much better than it did before he got here. And so he's going to take some time to walk you through that today and also discuss some of the history of ACCRE, which was really interesting to me. I think he knows more about ACCRE's history than I do in some ways. And also give a brief demo of how easy it can be to use the ACCRE cluster.
Thank you. So welcome everybody, and welcome everyone on the live stream. Can you hear me on the live stream? Just leave a note on the live stream if you can hear me. I just want to make sure that it's working all fine. But I work at Vanderbilt, and I am in charge of a bunch of projects throughout the university. I'm part of the Physics and Astronomy department, and I'm part of the Initiative for Autism Innovation in the Workforce. And for the purposes of this talk, I am a part of ACCRE, the Advanced Computing Center for Research and Education. And today I'll be giving an overview of ACCRE and its history, and I'll give a brief demonstration on how to use the ACCRE cluster. So this is the ACCRE website that I have worked on for the past year, and it is pretty. And we use the Vanderbilt look and feel, and I've worked hard to make sure that it is organized well. Hey, I see it's raining outside. I see students running from class to class and forgetting their umbrellas. And it took some. And for comparison, this is the previous website, and we had links all over the place, and it was not immediately clear where to click on to create an account with ACCRE, or get the cluster utilization, or just basic stuff. And what I did to organize it further. By the way, I also have some previous versions of the ACCRE website. This is 2007. This is back when we were one of the fastest supercomputers in the world at the time. And this is 2002. Back when ACCRE was known as Vampire. And the logo for Vampire was the Linux penguin dressed up as a vampire.
Al, do you recognize that?
And then you can go even further back than that. This is where it was back in the 90s, and you can still go to this website today, and it looks like it hasn't changed since the 90s. And then even further back, if you look over there, you'll see a round building. That is actually where Vanderbilt used to keep its IBM mainframe back in the 60s. And eventually they turned it into the Bionuclear Magnetic Resonance Facility, the BNMR facility. And when they converted it for that purpose, they drilled a hole in the ceiling. This is the story that I was told. They drilled a hole in the ceiling, and they pulled out the main frame, and they put in the new machine, and then they built a new ceiling. It's pretty interesting. So in order to develop the website, we sent out a survey last year. If you filled out the survey, thank you. We got a lot of responses, and they were very helpful in telling us what is on the website that is useful and what we could improve. And also, we went to other websites that are similar to the ACCRE website. This, for instance, is the San Diego University of UC San Diego. The UC San Diego High Performance Computing Center, and I also thought that it was well organized. There are sections for researchers, sections for the general public, sections for students who are looking to get involved, many different blurbs about research that is being done, and then there's a section, and then there's a nifty place to click on to check on the status of the cluster. And then we also did some usability testing. So when you do a usability test, you bring someone into the room, and you tell them about, and then we have two cameras, one that is being screencast. We have a screen recording of the screen, and then we have a video recording of the person trying to click on things. So then we tell them, okay, I want you to get the cluster utilization page, or okay, I want you to create an account. And then we check to see how long it takes for them to find the necessary page, and what do they click on first. And that can tell us a lot. If we tell them to do one thing and they click on the wrong link or the wrong section of the page, that tells us, okay, maybe we should consider putting that page in that section. And it's based on a book that I found in Stevenson Library. It's called Don't Make Me Think, and it was written, I think, around 2000, and it's one of the few technology books that I still find useful. In fact, whenever new students come in, one of the first things I tell them is to check out this book from the library. So then I ended up with this useful map of where to put everything and what the main sections of the page should be, and then this became a useful way for getting started with the website. So a lot of departments around the university use ACCRE. We have people using it every place from chemical biology to genetics to evolution to astronomy and black holes, and you can read through some of the ways that people do research on the ACCRE website, and we're looking to expand this section. So if you're doing interesting research with ACCRE, we would love to hear your story as well. Another thing that we got to do while building the website is we brought in one of the Vanderbilt photographers to take pictures throughout the data center. So this is the ACCRE Data Center, and it's on Peabody campus. Maybe you've seen it before, and it used to be the dining hall for Peabody College before the Commons was built, and after the Commons was built, they turned the old dining hall into the data center for ACCRE. and this is what it looks like as you're walking down the different clusters. And one thing you'll notice as you walk through the data center is that some of the corridors are cold and some of the corridors are warm. And this is all in an attempt to make sure that the servers are kept cool so that they don't overheat. Air circulation is really important in designing a cluster or any sort of data center. And if you turn the lights off, then you get all these. Then all you see are the blue LEDs, and it looks very interesting. And we have a lot of those shots on the website. So how do you get involved with the ACCRE cluster? Do you just walk in and hopefully there's a monitor and then you just type stuff in? No. Only people that are authorized by the UIT can enter the data center, and we only go in there to do occasional maintenance. For the most part, if someone wants to use the ACCRE cluster, they will use a secure shell client. This is what the secure shell client looks like in Windows. It's called PuTTY, P-U-T-T-Y, and then you'll do some configuration, and then when it's all done, you can just double click on a button, and then you'll end up on, and then it will look like this. And you type in a username and password, and you get this lovely set of ASCII text that says ACCRE cluster, go forth and compute, and then you'll be ready to type in commands. And then as you're typing stuff in, every letter gets sent to the cluster, and then as the cluster is generating results, it gets sent back to the monitor. So it's like you're in front of the computer, but not really. So there are a lot of reasons why people use ACCRE, and a lot of people use ACCRE because there are large processors and memory and CPUs, and some people use the graphics processing units on ACCRE to do even more advanced calculations. As you might remember from the last pizza and programming session, graphics programming units were originally designed to do graphics for video games, and then eventually people realized, we can do this to do high capacity computing as well. So we have GPUs on the cluster now. Other people use ACCRE because all the software is pre-installed. You don't have to go through a large amount of work to get a certain piece of software installed. Everything is just built in, and in many cases you can just call up a piece of software using an lmod command, which I'll explain in a little bit, and then you're good to go. It's also reliable compared to running a piece of code on your laptop. If you do that, there's a good chance that eventually your laptop will say, oh, I need to install an update, and I need to restart the computer. Meanwhile, if you run it on ACCRE, you don't have to worry about your laptop running out of batteries, or the power going out, or your software, or your operating system deciding to update whenever it wants to. It just keeps running. Those are just a few of the reasons why ACCRE is so useful. We have support on standby. If you need us, we're happy to help. with installing software or getting software to work, or if there are any problems with the ACCRE cluster. And we also do tape backups every day. Every day, we do a tape backup in case anything goes wrong. So this is a basic diagram of how a supercomputer works. So when you do the terminal commands, what happens is you're interacting with one of these computers over here. Those are the gateways. And if you want to do more intense programming work, then you'll want to schedule a job. And so you'll tell the scheduler, okay, I have this big job that I need to compute, and I don't want to waste the gateway's time. I want to pass it along to the nodes. So you send it to the scheduler, and then the scheduler will pick a node to complete the task. It may call multiple nodes to complete the task, and then it'll send the stuff back to the user. And along the way, there's also an authentication server for checking usernames and passwords. And then there are also a bunch of file servers. And the file servers are like Dropbox, but they're on the supercomputer. So it's a useful way for getting results, but also sharing files with others. So this is on the new website. It's a step-by-step process for how one would get started with ACCRE and set up an account. The way that it works is you would have to be part of a group that does research with ACCRE, and if you're a PI and you want to work with us, there's a 4-month SkyView, and you fill it out, and then we would approve you. And if you just want to try out ACCRE, you can do that free for a few months, and then we have reasonable subsidized rates. But if you are part of a group that does research with ACCRE, then you would fill out a cluster account form. Then you would be approved by your PI, and then you would download this terminal client. If you have Mac or Linux, you don't need to get PuTTY. Everything is already on your computer. And then there are other useful programs. There is you can have a secure copy client if you want to transfer files to and from your computer. And there's also the X Window system. We don't really recommend using the X Window system, but it's useful for if you want to have if you want to get images to and from, if you want to interact with ACCRE the way you would interact with a normal computer. And I can show you what it looks like, but it's really slow, and for the most part, we recommend people use the terminals as I'm about to demonstrate. We have 3 training courses that people need to sign up for. That is Intro to Linux. If you don't know Linux already, there is Intro to the Cluster, and there is Intro to Slurm. And we require that everyone who's involved with ACCRE complete those within a few months of within 2 months of receiving their accounts. we normally have them Tuesday, Wednesdays, and Thursdays at 2:30. And if those don't work for your schedule, then you can sign up then you can submit a help desk ticket, and we can arrange to do it at a different time. And then there's also a tutorial of ACCRE's basic functions, which I'm about to show you. We also have a big documentation section. So it goes over Linux, it goes over LMOD, it goes over Slurm, it goes over GPUs and parallel processing and everything that you would need to know to get involved to work with the ACCRE cluster. And I can show you what it looks like. So this is ACCRE commands for job monitoring, and there's a subsection here that will show you where you can jump from one part to another. And this is page for GPUs and parallel processing. Let me just check the live stream page.
Sure.
Hey, well, can you check the live stream page?
Sure.
Okay.
What are you looking for on it?
I just want to make sure everything's.
You're streaming. Yeah, you're good.
Okay, so I've mentioned quite a bit Linux, LMOD, and Slurm, and for good reason. It is used quite a lot within ACCRE, and we emphasize it a lot. And Linux is the operating system. It is used quite universally among supercomputing centers. In fact, at this point, 500 of the top 500 supercomputers in the world use Linux. And Slurm is the software that we use to interact with the server, with the scheduler, I mean. And then we have LMOD, which is developed by the Texas Advanced Computing Center at the University of Texas, and that is used for pulling up pieces of software. So I can tell LMOD to call up MATLAB, to bring up MATLAB, and then I can use MATLAB without having to go through the installation process. I would still need a software key to use MATLAB, but that's one of the nifty things about ACCRE. Everything is being installed. So now I'm about to give a brief tutorial on how to use ACCRE to calculate 1 million digits of pi. We just had Pi Day, so I felt this is pretty appropriate. You could do the math for calculating pi. This is the Chudnovsky algorithm, and this is used to calculate pi to trillions of digits using powerful computers. So we're not actually going to use this today. We're going to actually use a software plugin. We're going to use a library within Python. So if I do this I can do this with 4 lines of code. And this will use a Python library called mpmath, and assuming that mpmath is installed, we can do 1 million. We can calculate 1 million digits of pi just by typing out this code. And we're going to add a few more lines just to make it more just to help us out a bit. First, we're going to set it up so that we can do variable digits of pi. So we can, maybe instead of 1 million digits, we can do 100 digits or 1,000 digits, just to test it out. And then we're going to add a few more lines to time how long it takes to calculate pi. And then finally, we're going to add a print command before and a print command after, just to say things like pi is approximately equal to, and how many digits were calculated and how long it took. So now we're good to go. So I'm logging into ACCRE, and this is the ACCRE terminal, and I've set it up so that it's full screen and at a larger font so that you can all see it. And I've put everything in this directory, and let's see what files I have in here. I have pi.py and I have pi.therm. And this just has all the code that I showed you previously. And if I do Python pi.py, let's calculate it to 100 digits, just to see that it works. Oh, that's because we didn't do the lmod command. So module load Anaconda 3. So Anaconda is a variant of Python, and it has tons and tons of Python libraries that we can use. And in this case, it has the mpmath library that we would need. So let's run it. So let's do the module load, and now we can do Python pi.py 100. And now we should get Python to calculate pi to 100 digits. There you go. So how about 1,000 digits? Sounds good? So we could go ahead and type in 1 million digits, but then we would be running it on the gateway, and that seems like an awfully big task to give it to the gateway. Maybe we should give it to the node instead. So in order to help us out, this is where Slurm comes in, and so I've written out a Slurm script, and the Slurm script will says okay, we're going to use this module, and we're going to run this command, calculating pi to 1 million digits. And along the way, we have some settings we can put in. These are called sbatch directives. And if you look in your cheat sheet, you'll have we'll have a section full of sbatch directives you can put in. So I'll walk you through the directives. So this says, okay, we're going to keeps this person posted by email, and we're going to send him all the alerts. So if so we're going to send an email when the job starts and when the job finishes, and if there are any errors, we'll send it to that email as well. And we only need one node and one task and 2 gigabytes of memory, and we want to output it to this file. And if it takes longer than 20 minutes, then we stop the job, and that means that something has gone horribly wrong, and we should stop the job and let that person know. So now we're ready to submit the job, and the command we run is sbatch pi.slurm. It's sbatch, right? Yes. Okay. So this sends the job over to the scheduler. And sometimes it can be slow, and now it's been submitted. So we get this job, and the job ID is 25847925, and I should get an email just right about now, saying that the job has started. And while the job is running, we can check on its status. So I believe it is FQ. What? Dash U. And then the ViewNet ID. So it has been running for 30 seconds, and I can just keep pushing enter on this. 40 seconds, 45 seconds. $50 seconds. 57 seconds. 1 minute. It should finish at any moment now. 1 minute, 7 seconds. 1 minute, 15. 1 minute, 18. 1 minute, 21.
And then the capital R tells you that it's running.
Yes.
You can also see where the job's running.
Mm-hmm.
UP 1008 is the name of the node when the job's actually running.
All right, so now we see that the job is gone, and now we can go to let's see what files are here now. So now we have pi.txt here, and let's see what's inside. There you go, 1 million digits of pi.
Who wants to recite that? How much time we got?
And if we scroll all the way to the bottom, $1 million digits in 90 seconds. So this is one of the few things that you can do with ACCRE, and there are many ways and and this is one of many. There are tons and tons of software packages and libraries on ACCRE, and if you're and so if you have if you have and there's a good chance that one or more of them would be useful for your research. So we hope that you can find this useful, and our website is vanderbilt.edu/ACCRE. And if you have an old URL somewhere that has the old www.acre.vanderbilt.edu URLs, those should redirect to the new website. So that's all that I have. I wanted to show you what the X window system is. So I can just type in Firefox, and then I'll get a new window, and I'll need to have this open. So if I type in Firefox, and eventually I will get a new window, and it will be Firefox. So this is what it looks like. So this is running on the ACCRE server, and as you can see, it's really slow. But if you just want to get if you're running a firm script and you want to the result is an image and you just want to get the image quickly, this is a good way to do it. But as you can see, you just click, and then it takes about a second to open a new tab or jump to a website. So we don't really recommend this for daily use. But that's about it. Do you have any questions? Yes.
So we've had folks give lectures and telling us how to use Jupyter notebooks to time when we compute nodes and do things, and that's got to be X42, right?
Not necessarily. So Jupyter notebooks are also really useful, and I don't remember the command to run a Jupyter notebook, but that uses tunneling. So if you have so for instance, you can set it up to tunnel port 8000, and then you might have some software that is running, and that means that any program that means that if there's a server running, then you can go to localhost 8000, and then you can use a web browser just as if there was a website somewhere.
So the browser is running all local traffic, probably, right?
Mm-hmm.
Just data going back and forth.
Anything else? Yes.
Are there instructions for if a user has a new kind of library or software that they need for their work that's not already among the pre-installed things? Is there a process described for users to request?
So the way to do this is to submit a help desk ticket.
And sometimes sometimes we can install the software cluster wide. If there's lots of users who need it especially, we'll go ahead and do that. And if not, in the worst case scenario, we'll sort of hold your hand through the process of installing it locally and making your own software.
And what about virtual desktop? So on my group's workstations here in the building, we use something
trying to set up a web portal so that you can actually use that, basically using VNC server, which is helping us see what's going on. There's a whole suite of stuff that you can do. It's just really we're kind of trying to focus on trying to get the CentOS 7 kind of out the door, and then we'll kind of work on that. But yeah, that will, once we get that, you'll be able to do things like go to a web service, go to a web portal, log in. It'll automatically do kind of like an S-batch, land on a node with X number of cores that you're requesting for your requirements, and then you can kind of just submit your, you can submit your graphical MATLAB or things like that, and it'll automatically then kind of fire them up. But since it's using the NC server, it goes much quicker.
Yeah.
The X11 protocol, if you ever look at it at the low level, is super chatty, and it wasn't designed for WAN networks. It was really designed to be kind of like next door, literally kind of connected, to a computer. And that's one of the X11 displays I always think forever and a day. Is that if you look at it, it's just super duper chatty. Instead of it kind of just like sending a raw image back in one fell swoop, like a modern browser is designed to handle, it's going to send it back kind of piecemeal back and forth with a handshake on each one of those.
Yes.
How often is the software updated? That's something
I guess it depends.
Yeah, our current plan is to do that roughly every 6 months. So we have like an entire stack of